Turn your page to, your INB to page 70, and we are going to work out this INB. This INB, we're going to explore what happens if we add or subtract numbers to our parent function. So the first problem we're going to look at is f of x is equal to x squared plus 2. So if we notice, we see our parent function in that equation, which is f of x squared. So notice a 2 has been added outside of the function. And so we're going to plug in the 3 key points to our quadratic, and we are going to evaluate. So I'm going to plug -1 in for x squared, and -1 squared is 1, 0 squared is 0, and 1 squared is 1. And I'm going to come over here and I'm going to graph my parent function. Might graph a couple extras. 2 squared is 4, -2 squared is 4, and 3 squared is 9, and 3 squared is 9. And here is my parent function. We've already looked at this function. Now we're going to see what happens when I add a 2 outside of this function. So now I have y is equal to x squared, and I'm going to add 2. So let's start with the same values, -1, 0, and 1. And I'm going to plug them in there. -1 squared is 1 plus 2 is 3. And I'm going to plug in 0, 0 squared plus 2 is 2. And I'm going to plug in 1, 1 squared is 1 plus 2 is 3 again. I'm going to graph these functions. So I have -1, 3, 0, 2, and 1, 3. And if I notice what happened is it looks as if my function shifted up 2 units. So as if I took that the graph in the black and I just pushed it up 2 units and slid it up, it would be right where my red function is. So let's look at the next one and see what happens there. Right off the bat, I'm kind of thinking, I bet this function will shift down 5 units since this one seemed to shift up 2 units. So let's try it out. So the first thing I notice is this function says the absolute value of x minus 5. I see the parent function. It is just the absolute value of x. Now I'm going to plug the key points in, and I'm going to evaluate. I'm going to put -1, absolute value of that is 1, absolute value of 0, 0, absolute value of 1 is 1. So I have the same 3 key points as the quadratic, but we should know that the shape of a absolute value is 2 straight lines. It makes a V. And then now what I want to do is look at the transformed. So what did this transform? What did this -5 do? Let's take the same 3 key points. Let's plug them in. Absolute value of -1 is 1, -5 is -4. Absolute value of 0 is 0, -5 is -5. Absolute value of 1 is 1, -5 is -4. So I'm going to graph these: -1, -4, 0, -5, and 1, -4. And exactly what I thought happened. Looks like all these points just shifted down 5 units. So if I just could have pulled my graph, my black graph, the parent function, the absolute value of x, down 5 units, it would land right on top of this transformed absolute value of x minus 5. So what can we state here? You can say when you add or subtract a number outside the function or parent function, right? The function shifts vertically. The same sign relationship, meaning if it says +5, it's going up 5. If it says -5, it's going down 5. Um, and so we'll look at what happens if we add or subtract a number inside the function next.